Hi everybody. In this lecture I thought what I'd do is give you some nice base 8 examples. Some of these examples are going to come from the homework, so it might be worthwhile paying attention. Let's assume you have numbers like 7, 7, base 8. Notice we do not say 77. If we ask basic questions about the bases, for example, what could this be in base 2? Well, a simple lookup table gives us 1, 1, 1, 1, 1, 1, and that's our base 2 answer. But then if we want to know the question, well, what is it going to be in base 16? Well, we group by 4, and now we say the answer is 3F, base 16. And then if we say, well, gee, okay, what's the value in decimal? That's base 10. Well, then the answer must be 7 times 8, which is the base, raised to the 0, 1 power, plus 7 times 8 raised to the 0 power, which is equal to 56 plus 7. And suppose somebody comes along and says, okay, that's very nice. Suppose I have a binary number and I want to convert it to to base 8, right? So we start with binary, we want to convert to base 8. We'll start with something like this: 1 0 1 1 1 0 0 base 2. What could that be in base 8? Let's take a moment and think about this a moment. And what do we do? Well, I look at it a different way. I say, well, there's 3 and 3. I group by 3. And now I look at it and I say, that's a 4. And that's a 3. And that's a 1. So the answer must be 1, 3, 4. And that's going to be my base 8 result. You say, well, wait a minute. What if I want base 16? Well, then I group, instead of by 4, I group by, instead of by 3, I group by 4. And so here's my grouping by 4. And now we have to do a lookup, right? This is going to be equivalent to 8 plus 4, which is equal to 12. And if we think about it, in base 16, it's A, B, C, 10, 11, 12. So that must be a C. And then this must be a 5. So I have 5C, base 16. Well, how did we get this over here? Well, we know that in hexadecimal, we number 0 through 9. And then we have 10, 11, 12, 13, 14, and 15. 9 corresponds to 9 in base 16. So we write on the top r equals 10, r equals 16. But 10 is an A, 11 is a B, 12 is a C, 13 is D, 14 is E, 15 is F. And from these basic symbols, we can write down the decimal equivalents. 1, 0, 0, 1 is going to be 9. 1, 0, 1, 0 will be A. 1, 0, 1, 1, B. 1, 0, 1, 1, 0, 0 will be C, which is what we saw over here. 1, 1, 0, 1, and 1, 1, 1, 0, and finally 1, 1, 1, 1. So we have a direct mapping between the symbol on the right and the binary on the left. Thank you.